Hello everyone, in this lesson we will implement the algorithm for listing binary numbers of a given length. So open Visual Studio, go to File, New, Project, Win32 project, let's say here listing binary numbers, press OK, and next, console application, empty project, and make sure nothing else is checked, and finish. Okay, add a new file, source CPP is okay, and we're ready to go. Include IOStream using namespace standard and the main function. Let's make a quick check that everything is okay. Everything seems to be okay. And the easiest thing to do is list all the binary numbers of a single digit. So we just need one digit. We can initialize it with 0 first, and then we could output it. Let's see. We have a 0. And if you want to list the other single digit binary number, we have 0 and 1. Let's list them on separate lines. We have 0 and 1. Okay. Now we see that we have some repeated code over here, so we can get rid of it. And we have 0 and 1. Now, let's list all the binary numbers with 2 digits. So we'll need another digit, call it b. And we could initialize b with 0 here. And we will list it here. And then we can do the same thing, but this time initialize b with 1. And let's check what we got. So we have all the binary numbers with 2 digits. But again, we have repeated code, so we'd like to get rid of the duplicate code. Let's say the same thing for b. Don't need these anymore, and we can nest the for loops, and this can go away. And let's check that we get the same thing, and yes, we get the same thing. Let's do one more digit. Another for loop, but this time for c. And we'll output here C. Run it, and we have all the binary numbers with 3 digits from 000 to 111. Now we don't like that we have 3 variables here. We could use only one variable, a vector or an array. So let's do that. Get rid of these, and now we'll say this one is a of 0, and we don't need this anymore. This one is a1, and finally a2. And here we'll just list A0, A1, and A2. Let's check that everything is okay. And we still have the binary numbers with 3 digits. Now what we'd like to do is again get rid of the duplicate code, because we see we have several for loops, and we can make a function that could basically do this. And then call itself. But of course the first problem is that the function doesn't have access to the array, so we can fix this easily. We'll put it here. Now the next thing, we see here that the function calls itself, but it needs a parameter. What we see here is that the first time it goes to the first element of A, and the second time it should go to the second element, and so on and so forth. So if the function would get a parameter p, then when we call it recursively, it should call list of p plus 1. And here we need to have p. And we're not exactly finished, because we need a stopping condition. We see that as it is right now, the function would keep calling itself recursively, so there is no way this function would stop calling itself. So the end condition would be when p is equal to 2 in this case. So we could just write it down like this. If p equals 2, then we just see out the elements. Otherwise, we make the recursive call. Okay, let's test it. We'll go in the main function and call list from the first element of the array, from 0. And let's run. And we get the same thing. Now, what happens if we want to list binary numbers with more digits? Then we would need to introduce a new variable n. Let's say n is a constant for a moment. Now the condition here becomes n minus 1. And we have to get rid of this and make a new function. Let's make a for loop. And print out the new line. Here we can just say print. Let's test. And we get the same thing. Only now we can easily change n equals 4, and we get all the binary numbers with 4 digits. We have just implemented the brute force algorithm, which is a special version of the backtrack algorithm. We will go into further details in future lessons.